Welcome to this introduction to interfaces with Pact. Throughout this tutorial, you'll learn why interfaces are valuable and how to implement them within your Pact applications. More specifically, this tutorial covers the following topics. I'll start by introducing interfaces, describe interfaces and modules, show you how to declare interfaces, and how to work with them. Finally, you'll see how to declare models in an interface. We'll wrap things up with a demonstration of a coin contract that makes use of each of these features. The key takeaway of this tutorial is that interfaces allow you to provide access to functions within one module to another module. They're defined using the interface statement and can be accessed from within modules using the implement statement. Interfaces are the point where two systems meet and interact. This definition includes people, organizations, electricity, or any other interactions you can think of. For example, a light socket is a type of interface that gives you access to electricity. In programming, interfaces work similarly, but are used to allow interactions between programs. This isn't specific to Pact, so if you're familiar with other programming languages, you likely have come across this idea already. If you're unfamiliar with interfaces, you may have at least a basic understanding of what an API is, which is an application programming interface. As you might know, many programs have APIs that allow you to build programs that give access to specific data. For example, you could use Facebook APIs, Twitter APIs, Google APIs, or any other API to add functionality to your application that you wouldn't have otherwise. Aside from that, you may be familiar with a UI, known as a user interface. These types of interfaces give users access to elements of a program without using code at all. There are many types of interfaces that have both high and low-level use cases in programming. In this tutorial, you'll focus specifically on building interfaces using Pact that allow users to create interactions between modules. An interface, as defined in Pact, is a collection of models used for formal verification, constant definitions, and typed function signatures. They contain API specifications and data definitions for smart contracts. These include each of the following elements: function specifications, constant values, and models. Using these three elements, you can both declare and create an interface. First, declare an interface using the statement interface, followed by its name. After creating an interface, you'll sometimes want to be able to import an existing module. You can do that with a use statement. In this case, you can see the example interface is using an example module. Using a module will allow you to do things like import constant definitions that may exist within the module. Alternatively, sometimes it will be the other way around, and you might want to access an interface from within a module you created. You can do this with an implement statement. As you can see here, the module myModule is implementing an interface named myInterface. Like before, this gives you access to some important functionality of the interface from within the module. So we kind of breezed through those, but we'll have a look at these in a demonstration later. So for now, just know that they exist, but don't worry if it's not quite clear how you would use them. Let's dive into a couple more specifics of modules and interfaces. As you learned, interfaces allow modules to communicate information between one another. They look very similar to each other, making them simple to program, but there are some key distinctions and ideas that are worth noting. First, interfaces cannot be upgraded, and no function implementations exist in an interface aside from constant data. Also, when working with interfaces, it's important to watch out for conflicting module functions. That's because multiple interfaces can be implemented by a single module. If there are conflicting function names across multiple interfaces, then the two interfaces are incompatible. In these cases, you need to either inline the code you want or redefine the interfaces to resolve the conflict. Similar to that idea, interface names need to be unique within a namespace. After implementing an interface, you can access the constants declared within an interface using their fully qualified name, as shown here, interface.const. This makes it so that they don't have the same naming constraints as function signatures. Finally, interfaces may make use of module declarations. This allows interfaces to import members of other modules. For that reason, interface signatures can be defined in terms of table types defined in an imported module. Using the basic ideas described so far, you can create complex interactions by defining interfaces and modules along with the implements and use statements. To start, take a look at the example here. It declares an interface named myInterface, including a function named helloNumber. After this interface, you can define a module that implements myInterface and makes use of the helloNumber function. Notice that within the module, a function named square3 is defined. This function makes use of a constant defined within the interface named SumConstant, having imported it with the implement statement. Take some time now to understand how this interface and module are interacting and think through how you might use this in your own applications. Next, here's an overview of declaring models from within an interface. Formal verification is implemented at multiple levels within an interface in order to provide an extra level of security. Similar to modules, models may be declared either within the body of the interface or at the function level in the same way that you would declare them in a module, with the exception of schema invariants. You can't declare tables or schema in an interface because there's no abstract table or schema that you can define or implement in a meaningful way. It also couples a module too tightly within a particular interface. You can, however, import a module and use the declared table and schema in that module as types in the function signatures or in the models. Models that you specify in an interface will be added with additional models that you declare in a module. This allows you to layer more constraints on as you wish for your business needs in your module. And that's hopefully enough to get you started with declaring models in an interface. What we'll do next is put some of these ideas to use with the coin contract demo. So, for the rest of this tutorial, you'll take a closer look at interfaces using a version of the coin contract from previous tutorials. Rather than using the tutorials GitHub repo like previously, you'll find this project within the Chainweb node repo here. If you don't know, Chainweb is the Kadena public blockchain platform that Pact code runs on. We haven't discussed this in previous tutorials, but you'll see a lot about this as you get more experience with Pact. You don't need to know what Chainweb is for this tutorial, but if you'd like, you can learn more about the basics of Chainweb at the Kadena blog. To get started with the demonstration, clone the project and open it in Atom. Type git clone followed by the Chainweb node repo, then enter the project directory, which is within Chainweb node Pact coin contract. Finally, open the project in Atom. Looking at the interface, you'll see that it includes functions. These functions contain inputs and models, allowing for the basic functionality of managing coins to be used by other modules. Let's take a closer look at this code to get a better idea of how it works. First, define an interface using the interface statement followed by the name of the interface, in this case coinsig. Within the interface, you'll create each of the functions. First, the function createAccount takes inputs account and guard. Within this function, a model is defined checking that the account is not an empty string. This will ensure that each account is given a name. Next, transfer allows users to transfer value between a sender and a receiver. It checks that the amount is greater than 0 and that the sender is not also the receiver before completing the transfer. Note that the function transfer transfers coins to a known account. This function fails if both accounts do not exist. Since this function could fail in that case, there are times you might want to take a different approach. In that case, the next function, transfer and create, could help you. It will both create the account and transfer value to it in the case that the account doesn't exist. This function supplies a guard for the receiving account. If the account exists, it checks to see if the guards match. If they do, it will complete the transfer. Otherwise, the transaction will fail. If the account does not exist, then the account will be created and the coin will be transferred to the new account. Moving on, the function accountBalance takes an account string and returns the balance of the account. AccountInfo takes a given account and returns data including all of the account's information. And finally, the function Coinbase allows users to mint tokens to an address by defining the address, address guard, and amount. Having created each of the functions within the interface, you can now create modules and use them for whatever purpose they might serve within your application. So there's a brief overview of the code that makes up this interface. There's a bit to walk through here, but hopefully you're already familiar enough with functions to have a basic idea of what's going on. The key idea here is that the models and the functions will be added to the property of models of the functions in the module that implement this interface. Take some time to look through these files and see how this interface is being used. For example, if you navigate to coin.pact, you'll see that it implements coinsig and uses some of these functions. Understanding this will give you a great start toward using some of this functionality for yourself. And that wraps up this introduction to interfaces with Pact. Throughout this tutorial, you learned why interfaces are valuable and how to implement them with Pact. We introduced interfaces in more detail and described how they're different than modules. From there, you learned how to declare modules, how to work with interfaces, and viewed a demo app that put these basic ideas to use. Take some time now to explore these ideas further, study the code demonstration, and try building an interface for yourself to get a better idea of how you can use them in your future applications.